So now that we've seen lists, we can talk about for and iteration in Python. So let's see some examples. Let's define a list of names that are just completely random and, don't expect any structure there. And then for every entry in this list, I'll print the last letter. So I think everything here should make sense to you, and you can see the first for in action. So this would print that Goofy's last letter is Y, Daisy's last letter is Y, Mickey and Donald. Okay, and you can see here that the for statement, the for loop, expects that some indentation appears, and then you have the block of the for loop. So for every n in names, n will be essentially assigned all the entries of names in turn, and each time n is assigned a new value, the body is executed. So print n's last letter is, and then n minus 1 accesses the last entry in the string. Okay, so that's one way of doing things, and maybe I should mention first, before going on to further examples, range. So range is a convenient way to generate some lists of integers. So here, if I type range 10, I'm asking for all the integers up to 10, excluding 10. If I type range 210, I'll ask for all the integers between 2 and 10. And remember, this is closed on the left, open on the right. And here I ask all the integers between 0 and 71, and with skips of 7. And you can see it there. So it's clear that range helps us create lists of integers, and then it makes sense that we will want to iterate over entries of those lists. So let's see an example, and an example that will actually show us also how to use break. So here I have done a for, and for n in range 10. So range 10 will be from 0 to 9, and then I assign to n, to the variable name n, the objects 0 to 9 in turn, the integers 0 to 9 in turn, and I print n. Okay, so you would expect this to print all the integers between 0 and 9 included. But actually that's not the case. We stop at 8. Why do we stop at 8? Because inside the body there is something called break that has been used, and basically if n is equal to 8, then what follows is executed, the break. And the break, what it does is that it basically says, okay, now exit the for loop that you're sitting in. Okay, so at 8 we've decided to exit the for loop even though we were not completely done with the for loop. Okay, so that's a new construct. So here is an example of how to use it. So here we'll use the break to compute the square root of 2 within some range. So how will that work? Well, we'll define some epsilon, and this epsilon will be 10 to the minus 10. And then we'll assign, we have x, which will, or x old, which will be our approximation to the square root of 2. So in this case, we start with 1 and the float 1. Okay, and then we'll repeat 50 times, or at least we think we'll repeat 50 times, defining a new approximation of square root of 2. And how do we do this? Well, if you think about it, what we'll do is we'll average x old and 2 over x old. So one of those two, I don't know which, is below square root of 2, and the other one is above. So there are two cases, or they are both equal to square root of 2. Okay? So one is below and one is above. And so that means that if I take the average, I'll be actually closer to square root of 2, or at least the one that's further away will be closer to square root of 2. Okay, so I do this, I define a new approximation essentially of square root of 2, and then I print the iteration number, so which iteration am I doing now, and then I test if the absolute value of the difference between the new x and the old x is less than epsilon. So I'm changing x from x old to x new, and the question is, did I change it by something that I consider very, very small, this epsilon? And if that's the case, then forget about the 50 iterations, just finish. And if that's not the case, then replace x old by this new approximation. Okay, so it's hoped that we'll need less than 50 iterations to be within the epsilon tolerance. And if that's not the case, then we'll just stop after 50 iterations. So you can see here after running it that I only need 4 or actually 5 iterations to reach something that is within 10 to the minus 10 of square root of 2. Okay, so this is an example of why you might want to use a break. Now, another possibility is to use break with else. So let's see that. So here, what I will do, and I don't execute it quite yet, is I'll consider all the integers between 2 and 21, excluding 21, so really from 2 to 20. And a very simple thing to do is to check for every integer between 2 and n if n is exactly divisible by x, meaning if the residue mod x of n is 0. And if that's the case, I would like to indicate that n is equal to x times n over x. Right? I have got a factorization of n, and I would like to indicate that. And if that's the case, then I'll break the for loop. But wait, there were 2 for loops, so I'll break the inside for loop. Okay? And then I'll go again for an n that's bigger. If that's not the case for any of the inside for loop that n is exactly divisible by x, then, and here's the catch, I'll execute the else block. Okay, so if at the end of executing the for loop here, so I haven't found any exact factor of n, I'll execute the for loop. And in this case, well, I haven't found any factor between 2 and n minus 1 included, so I know that n is actually a prime number. So I'll print n as a prime number. Okay, so this is essentially taking all the n's between 2 and 20 included and printing one line, which is either a factorization or n is a prime number, or that number is a prime number. So we see that this indeed prints one line for every integer between 2 and 20 and decides to write what the factor is, or at least one pair of factors. Okay, so this is the break and the else statement, and now the continue statement. So the continue statement is also altering the flow like break and else, but in a more subtle way. So here I'll take all the integers between 0 and 9 included, and there will be an if that will test whether n is equal to 8. So let's consider what happens when n is not equal to 8. In that case, I just print n. So I print 0, 1, 2, 3, and so on, up until I reach 8. So in this case, the test succeeds. Okay? The test succeeds, and so I go in and I execute those. So first I'll print we will skip 8, and then I continue. So if I used break here, then I would just exit the for loop, and that would be it. But here I continue. So what does continue do? Well, continue tells me now exit that particular iteration of n. So I started this block with the value n equals 8. What continue does is that it says forget about this particular block, go back to the beginning, go for the next n in the list here, okay, and execute the block again. So with continue, I'm really skipping 8 essentially. I'm saying, okay, I stop now for n equals 8, go back, now n equals 9, and execute the block again. And you will see that indeed 9 has been printed at the bottom. Okay, so this was break, else, and continue used in conjunction with for. So here is another example of avoiding 0 with continue. So here I want to look at all the integers between -5 and 5 and eventually print the float 1 divided by n. Except if I do this, I'll have a problem because one of those is the integer 0. So I would do 1 over 0, which would cause a division error. So to avoid this, I do an if test. And if n is equal to 0, I want something specific to happen. I want to print inf to indicate infinity. And then I want to continue. And to continue, I remind you, we stop the loop there, go back, and reach for the next integer. Okay, so here I had -1. This was 1 over -1. And then 1 over 0, I print inf. And then I go on. I take 1 over 1, 1 over 2, 1 over 3, 1 over 4. So now we have seen how to use for, and we've seen that for combines with break, continue, and else. And from this, you can start actually building much more complicated programs now. And you'll have a bunch of exercises this week to test all that.